Good afternoon and good morning to those of you out west. Welcome to today's demo cast from the Construction Specifier and Kryton. My name is Farheen. I'm the Associate Editor for the Construction Specifier, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's demo cast, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the demo cast, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's demo cast is being recorded and will be available on the Construction Specifier's website by this time next week. Now, I'd like to introduce our speakers, Adam Creelman and Chris Woods. Adam has been sharing his knowledge and experience with architects and developers globally, giving him a firm understanding of how critical it is for the success of a project to be up to date with the best concrete, waterproofing, and durability practices. That's why he has carried on his work as a territory manager for Kryton International, a thought leader with 50 years of experience in providing top quality concrete waterproofing and durability solutions. Chris, with more than 18 years of experience working in the concrete industry, has a deep understanding of what makes a concrete construction project a success. Part of that comes from an extensive 10-year career working for a ready-mix supplier. He has currently bolstered his knowledge with contractor insights after transitioning to project management in 2016. With that know-how, he has supported a number of projects over the years for Kent Companies, the sixth largest concrete contractor in the US. In this demo cast, Adam and Chris will discuss best practices in abrasion and erosion resistance for specifiers. This webinar is designed for industry professionals who specify durable and sustainable flooring solutions that require high abrasion and erosion resistance, such as warehouses and heavy equipment facilities. This presentation will cover key considerations and challenges associated with abrasion and erosion, discussing their impact on the lifespan and performance of flooring systems, selecting the right materials and technologies, and exploring alternative solutions. Adam and Chris, thank you so much for joining us today. Please take it away.
Thank you so much, Farheen, for that introduction, and big thanks to Chris as well for joining us as our expert panelist. I'm just going to start with a quick rundown and review of concrete durability, abrasion resistance, and erosion resistance, why it's necessary, where we're seeing a lot of this in the industry. And then we'll talk a little bit about some of the, here we are. Then we'll talk a little bit about some of the industries affected most. Talk a little bit about some of the traditional methods that are used for to protect against abrasion and erosion, and some of the new innovations that just can make this process a lot more efficient. And then we'll get into the good stuff, which is me talking to Chris and then answering all of your questions as well. So really, when it comes down to abrasion and erosion, like a lot of things in the concrete, it is the cement paste that's doing a lot of the work, but it's also the weakest link when it comes especially to abrasion and erosion. And when that surface layer gets worn around or worn away, that's when we see the problems really start to accelerate. More water getting in there, more potential for corrosion in really aggressive environments as well when there's water involved. And really the functionality of that concrete structure and that concrete surface really starts to decline quite quickly. And this has a number of implications that people need to be aware of, owners, clients, especially concerned with a lot of these things, everything from safety, dust in the air, wear and tear on the machinery, just the efficiency of something like a pallet jack or different equipment going from place to place within a facility. Eventually, this leads to tripping hazards. Exposed aggregates can be slippery. And like I said, just the problem can really accelerate from there. Eventually, of course, leading to more and more repair and maintenance costs. And eventually, a lot of these facilities have to be taken out of service. Let's talk a little bit about where we see the need for these types of solutions to protect against abrasion. We are seeing a ton of this in warehouse and distribution centers. This category is growing like crazy in the States, driven a lot by e-commerce, which is still growing, expected to reach 22% of all retail sales worldwide in 2023. That was just 14% in 2019. So we can see that growth just continuing to happen in the United States, especially. We've seen just a massive uptake, just 4.2% warehouse vacancy currently in the United States. And then, of course, a lot of investment in infrastructure in Canada, United States, around the world at this point. So a lot of public money coming in, and that's where we see some of the demands for more sustainable solutions as well. And then in industries like agriculture can be a massive need for abrasion resistance, whether that's livestock, hooves, tractors, a lot of heavy machinery moving, those types of shop floors could take a lot of abuse. Some of the traditional methods that were used that we see out in the industry, and we'll be talking a lot about this with Chris later, some of these technologies and some of their limitations. Traditionally, dry shake was used quite a bit, spread, whether chicken feed style or with really expensive equipment to try to get a slightly more uniform application of dry shake, either mineral or metallic dry shake hardeners right into that surface layer, worked in, so with manual application. Then we are seeing quite a lot of liquid densifiers, and there's kind of mixed reviews on these technologies. Work great as dust proofing, nice shiny floor, and sometimes they have to be used in conjunction with dry shake hardeners. I'll talk to Chris a little bit about that. And then even more traditionally is just increasing the cement content. Of course, this comes with its drawbacks as well. Cement these days, especially, very expensive, and to get, to 100% improvement in abrasion resistance usually takes a doubling of the cement content of the mixed design of a cube of concrete. So we'll talk about these in a little bit greater detail. Dry shakes, really it comes down to that application being quite difficult. If you were to get the application perfect, I think that these can be quite a reasonably good solution to get that high hard mineral or metallic substance right into the top layer of the concrete. But of course, the application window at waiting for bleed water come to the surface really needs to get on there. Usually it's 2/3 of the material gets laid down, troweled in or floated, and then come back. They have to come back with the final third of the material and work that in to try to get that right. Not compatible with air entrainment, some compatibility issues with different supplementary cementing materials, fly ash, I believe, especially. And again, fairly major scheduling rest that Chris is going to touch on a little bit later. And then, of course, we get into the silica dust and the health hazards. This has been a major move by OSHA to crack down on silica dust on site. So that comes with extra considerations on site as well. So I think a lot of times this is seen as an easy economical solution, and not always the case, just with the number of limitations. Of course, it can't be used on vertical surfaces, and a number of implications there. Liquid densifiers, this is also post concrete pour. These are densifying materials that do react with that very top layer of the concrete. And again, it kind of locks in that the concrete surface really does help dust proofing and be quite useful for aesthetic treatment. Over time, there is a degradation factor, and there can be compatibility issues as well. And just a little bit on that abrasion resistance factor. Again, when exposed to actual abrasion resistance testing, these liquid hardeners, liquid densifiers tend not to perform particularly well, sometimes not at all compared to control. This could be just because it's just that tiny layer at the top. We could theorize a little bit about why this is the case, but again, for something like the Robinson floor tester or other testing methods, doesn't always perform when exposed to actual abrasion. And more cement, again, this does make the concrete harder, so is a proven method for reducing the exposure to abrasion, but with that cement becomes a number of limitations: curling, cracking, increased heat of hydration, and with that cement becomes, of course, higher carbon content for that project. And there is a better way, and it's an integral method by admixture, integral abrasion resistance added to the concrete at batching. And how this works is it's integrated directly into the concrete at batching, taking all that technology, all those complicated finishes, and putting it directly into the concrete, really taking away all of that scheduling risk. This improves the microstructure of the cement paste, which is that limiting factor, the weakest link for abrasion resistance. And this is capable of more than doubling the wear life of that concrete, drastically lowering that lifetime cost, the cost of potential scheduling delays, reducing the carbon footprint as well. And we can see the impact that it has on wear. This is, again, testing done with the Robinson floor tester, 800 pounds, going around 5,000 plus times, all the way up to 20,000 times. And really, as the wear increases, we really see the benefits of that full depth hardening that really enhances the microstructure of that cement paste. So now I'm going to turn to Chris Wood. How's it going, Chris? Thank you so much for joining us.
Doing well. Thank you for having me.
Okay, I've got a number of questions for you. So let's get right into it. Of course, Chris has been around the block in construction for some time, with his previous life in the ready mix community, and now on the concrete contracting side. So Chris, what are you seeing in the industry right now in terms of this demand for durability solutions?
It has increased over the recent years. The owner has taken considerations in their joint spacing, the life cycle cost of the entire building, their slab, and the importance of their slab is just at the forefront of every conversation we have in the warehouse and manufacturing realm.
Yeah, great. And today we're probably talk a lot about warehouse floors, distribution facility flooring, but of course HardSim is used in a wide variety of different projects, everything from hydroelectric dams all the way to transportation facilities and so forth. But Chris, what types of projects have you been working on where there's that added focus on durability?
A lot in the automotive industry. It's been a huge boom, especially in the Southeast, where we have the two ports of Charleston and Savannah. We've got a few tire manufacturers in this area. We've got some EVs starting to move in. They're putting some chip plants in this area, but it's a sprawl from that move of automotive into this area.
Yeah, we've seen a lot of projects for battery manufacturer, battery facilities of all sorts. Really seems like an explosion in this types of project. So Chris, pivoting a little bit to your experience, and one of the projects I believe you worked on recently did involve dry shake applications, maybe in earlier phases, or can you just tell us a little bit about that particular project?
Yeah, so there's a tire facility manufacturer in South Carolina, which we wrapping up the construction process of it. We actually were for dry shake right next to a hard sim application, so they're side by side. We got to the point where we told the general contractor, the owner, it's completely unconstructable without the use of hard sim in this area. They were adamant about the dry shake hardener in their main floor slab, but I think they became advocates of the integral hardener after the construction was done. It just took a little proving, but the whole construction process, the traditional schedule of construction is turned upside down when using dry shake hardener. And I say that because you pour the slab after everything in the building is complete. Normally, we would be pouring slabs early on, and then they're building roofs and finishes behind us. But as we all know, when we take other trades out of a traditional process, everybody is thrown on top of each other at the 11th hour, which is never good for anybody's schedule. But you know, some of the added costs that get baked into a concrete contractor's numbers, you know, there's smaller pours, you have more equipment, you have more labor, safety becomes a question and a problem because like you saw in the earlier slide, you saw the respirators, fit testing. I mean, just the processes and procedures have to be completely different. You got twice as much equipment, twice as many people, and they're all on top of each other in a smaller area, which makes it difficult to perform our task.
Yeah, so did they have some difficulty with that dry shake application before you got started with the hard sim?
Yeah, so this facility is quite large, and there was 3 contractors that did individual expansions before us. All 3 of them ended up tearing out 20 to 30% of their install. We were fortunate with a really small location of less than 1%, but the 3 before us are in the top 10 concrete contractors in the country. So we all had plenty of experience.
Yeah, geez, and can you contrast that with what your hard sim experience was like on that project?
Like I said before, it's half the equipment, half the labor. We installed it with a traditional size pour instead of a smaller size pour, which takes twice as long added to the construction schedule. So it was night and day as far as scheduling and logistics. The complexity was not there compared to dry shake applications.
Right. And then could you you mentioned that on dry shake applications, usually a surface or a sealer of some kind gets used as well. Is that common practice?
Yeah, so the manufacturer's recommendation is what we never want to buck or to deviate from. So we're almost handcuffed to the manufacturer's recommendations, which, you know, specify their acrylic sealer, their specific sealer. And so we applied that. Of course, a 30% acrylic sealer in a non-ventilated area, because the building is dried in and everybody's working inside of it. So that became a hazard. So we had to, you know, get everybody out of the building, work around that with ventilation, open everything back up, and it's just non-traditional methods.
And then are there mixed design considerations with dry shake as well that wouldn't be the case with hard sim?
Yes, sir. The with hard sim being an inert product, does not affect air, slump, all the fresh properties of concrete. It does a really good job of not affecting it, and that's the sleep insurance that we need as contractors. But I worked on the mix design for about 6 months prior to us even installing, just to get the most optimal mix design. We ran shrinkage testing on it. We ran bleed water testing. We ran every individual material test on every individual material, because every material set's different for each geographical location. So it's very specific to the materials that you have locally. You have to get the maximum amount of bleed water so that you can seed that dry shake, which then you have a window of opportunity that's very slim and has a high rate of failure. And that's why the previous contractors who worked on this specific job that I was talking about had a higher failure rate. But with my experience in the ready mix industry, it helped mitigate some of those issues I could get out in front of.
Yeah, no, I know sustainability as a topic may be greater interest to some in the audience, some of the specifiers in the audience, those involved with infrastructure, of course, than to use a concrete contractor. But maybe you could comment on what your clients really care about the most when it comes to sustainability. Maybe it's the efficiency of the project or the durability of the floor that they need to be functional for a long time.
Yeah, in the public sector, we do get a lot of ask about sustainability. I'm working on a hospital now, which it's a lead project. I do have one warehouse that's a lead project as well, but the sustainability is a big factor in the public side of things. In the private industry, they specifically look at schedule and dollars. Schedule's money for them, and the total construction cost was very important. So we never really got into sustainability. Mostly on the private side, it's not as paramount.
So on that topic of cost, a lot of people in the audience are probably wondering, well, how much does this cost? Does this cost a lot more than dry shake? So you're probably pretty intimately connected to the cost and details and what to consider when it comes to that cost to the owner.
When you look at the raw material side by side, hard sim versus surface hard, depending on the application rate, hard sim is going to initial cost be a little bit more expensive, but then once you get all the baked in labor equipment costs from your subcontract concrete contractor that may or may not be as transparent to get from them, you're going to see it's very comparable. Just the non-traditional construction schedule, it's hard to emphasize that enough, is you just turn your job site on its head when you go backwards. At the end of the day, after the job is all said and done, the sleep insurance plus a little premium makes a world of difference.
Great. Thanks for that, Chris. Lots more questions I could ask, but maybe it's time to pivot to some questions from the audience. Farheen, do you have questions for us?
Hey, thank you so much, Chris, and thank you so much, Adam, for this very informative session. We do have some time for audience questions. Just open the Q&A located at the bottom of your Zoom window and post your questions. We already do have a few coming in, so we're going to get started with these. The first question is, how did you get to learn about hard sim?
Yeah,
I'll shoot that one to you, Chris. What was your introduction?
So I had a local distributor that presented it to me, and we're always looking for a faster, more economical, better product. And I'll speak. I don't think we mentioned it, but when we talk about surface hardeners, we're only talking about 1/8 of an inch to 1/4 of the surface of your concrete, which in the application in South Carolina with 10 tire manufacturer, it's an 8-inch slab. So when they have a piece of equipment, forklift, whatever, fall, scratch the surface, that 1/4 inch to 1/8 inch is gone. So you have a gouge that now you've got the heart of your slab exposed, and it's unprotected. So the hard sim is throughout the entire 8-inch slab, which we had some equipment when they were installing. It's an extruder line for the tire manufacturer. And when the equipment installer, before it was opened up to the client, the equipment installer dropped and dragged equipment. And we were patching surface hardener floors before we turn over to the owner. And the same thing happened to the hard sim floors with no surface defects and no surface repairs. So I hope that answered the question, but I wanted to throw that out there as well.
Thank you so much. Have you ever had a landfill compactor drive on a slab? CAT 836K, for example, has steel lugs on the wheels.
So
Go ahead, Chris.
I've had dozers drive on the slab with very little effect, but I don't know if I've had specifically. You said landfill?
Yes.
Was it? Yeah.
Landfill compactor.
Yeah, I know.
Sorry,
we were involved in one project, which was an armored car, almost tank facility, where they used hard sim, and they still use I think they have kind of rubber shoes for those types of vehicles. So you'd still want to take those types of precautions just for the long-term success of the floor, but it has been involved in metal track facilities to add that durability as well.
And just to add to that, there's 2 transfer stations that I was going to rip. Well, I've got proposals on to rip out floors and replace with hard sim floors. So they understand the advantages to it. So they're looking to move that direction.
Thank you so much. Does hard sim react the same with type 1L PLC cement compared to original type F? Correct.
It's inert, so there is really no reaction outside of what its performance is supposed to do. But that's what we poured type 1L cement in South Carolina in our tire facility that we just installed. So yes, it works.
Thank you so much. Are there any specific project types or scenarios where you believe hard sim would be particularly advantageous compared to other options?
Oh yeah, I can take this. I mean, so we touched on a few of them as well. Some places where dry shakes can't be used at all, vertical surfaces, so for spillways and things like that. Of course, skate parks, often done with shotcrete. Can't be protected with traditional dry shakes. And then, of course, anything exterior, especially territory manager for the Canadian prairies, gets a little bit chilly up here sometimes. So there's a lot of exposed concrete that takes a lot of beating, a lot of de-icing salts and things like that being ground into the surfaces by pneumatic tires. And of course, they need air entrainment because of the freeze thaw concern, and dry shakes just can't be used with air entrainment. So hard-sem is a perfect fit for that type of scenario.
Thank you so much. You mentioned dry shake hardeners. So touching on that, compared to hard-sem, would you say hard-sem provides the same or better abrasion resistance, or does it depend on the scenario?
It does provide best-in-class abrasion resistance. There may be a couple of quite pricey emery dry shakes that would be comparable, but many of the dry shakes on the market would be lesser. And then, of course, that's for only a thin layer of protection, whereas hard-sem is that full depth protection and without the risk of delamination and all the things that might lead to having to completely redo your concrete floor.
Awesome, thank you. Are there any potential concerns or challenges you foresee when it comes to integrating hard-sem into a concrete specification?
Not that I am aware of. Again, the compatibility issues, it really is a plug and play product. Chris, do you want to comment on that? Anything that they really need to watch out for?
Yeah, we used, it's a handful of admixtures that was in the floor slab. I haven't used it with any shrink reduction admixtures or corrosion inhibitors, but we use the normal water reducer, the high range, with no issues whatsoever.
Thank you. Can a floor be polished if hard-sem is used?
Definitely, yes.
Yes.
Yeah, no concerns there.
Great, thanks. And are you able to discuss the additional cost per cubic yard compared to a standard slab concrete mix?
Yeah, Chris, do you want to talk a little bit about the cost?
Yeah, so a little bit of math I might have to do here.
Yeah, I don't know if we need to get into specifics, but kind of ballpark. And again, it's important to contrast that with the installed cost of dry shakes, of course.
Yeah, I mean, it does take a little math when you're talking about surface area versus volume. So it gets a little tricky. It depends on the slab thickness, depends on application rate of surface hardener, depends on how you bleed that over 1 million square feet or 20,000 square feet. So
yeah, it really does depend. That was something to keep in mind. And if you were dealing with a thicker slab, please give us a call.
Yeah, Adam Rod more than likely to help with trying to come up with a number if you need some help budgeting something or something like that.
Yeah, we do find 6-8 inch slabs. The economics are quite friendly, and if you're dealing with something thicker or any kind of unique application, please reach out, and we'd be happy to give you a quote or work with you on that.
Thank you so much. Is there a specification for this product? Is the spec for this product a standalone, or is it more simple, such as making sure the structural engineer has included it in their CIP section?
We do have a performance-based spec at Kryton.com under our specifications section, but often we do see it sole spec'd as hard-sem from Cementech or Kryton.
Great, thank you so much. Thank you so much, Adam, and thank you so much, Chris. And thanks to everybody who joined us today. That was all the time we had for questions. If you need to reach out with any additional questions, Adam's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we will be emailing the link to the recording to everyone who registered for the demo cast within a week. So keep an eye out on your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs better in the future. On behalf of the Construction Specifier and Kryton, thank you again for joining us and enjoy the rest of your day.
Thanks, Farheen. Thanks,
Thank
Chris.
you.
Thanks, everyone in the audience.
Thank you.